Notorious DJ.
The function is f of x equals 2x cubed minus 6x plus 2. Came from the book Calculus of a Single Variable. The authors are Edwards, Haid, Hostetler, and Larson. The year of publication, 2002. The city of publication, New York City. The company of the publisher, Houghton Company. The function f of x equals 2x cubed minus 6x plus 2 is under the category of algebraic functions, specifically the polynomial. It is a third-degree polynomial, so it also can be called as trinomial or cubic polynomial, because the highest degree is 3. It has 3 terms, which are 2x cubed, negative 6x, and 2. And then the coefficients of these terms are 2, negative 6, and 2.
Let's evaluate the given limit. The limit of f of x equals 2x cubed minus 6x plus 2 as x approaches a, where a is equal to 1. You can actually use the long method, but in this case, I just simply substitute 1 to x. The limit of f of x as x approaches to 1 equals, substitute 1 to x. So the equation should be 2 times 1 cubed minus 6 times 1 plus 2. Then simplify. The limit of f of x as x approaches to 1 equals 1 cubed is equal to 1 times 2 equals 2 minus 6 times 1 is equal to 6 plus 2. 2 minus 6 plus 2 is equal to negative 2. So the limit of f of x equals 2x cubed minus 6x plus 2 as x approaches to 1 is equals to negative 2. Now, we will be using the tables to approximate the values. We will approximate the limit f of x equals 2x cubed minus 6x plus 2. First, we will pick a value that is a little bit less than x equals 1, approaching to the left, thinking the standard x-axis. So this is our table of values. So let's start with something like 0. Let's write the 0 onto the x part of the table of values. Substitute the value 0 onto the equation. 2 times 0 minus 6 times 0 plus 2 is equal to 2. Let's write 2 at the f of x part of the table of values. Let's try 3 more x values to really get infinitely close to 1 from the left, we'll have x equals 0.5. That's right, 0.5 at the x part. Substitute x equals 0.5 to x. 2 times 0.5 cubed minus 6 times 0.5 plus 2. 0.25 minus 3 plus 2 equals negative 0.75. That's right, 0.75 at the f of x part in the table of values. Next, we'll have 0.99. 2 times 0.99 cubed minus 6 times 0.99 plus 2. 1.990598 minus 5.94 plus 2 equals negative 1.999. Next, let's try 0.999. Substitute 0.999. 2 times 0.9999 cubed minus 6 times 0.9999 plus 2. 1.999406 minus 5.9994 plus 2 equals to negative 1.9999999. Notice that we really get so close to x equals 1. Next, approach x equals 1 from the right, just like what we did earlier. Let's have x equals 1.0001. Two times 1.0001 cubed 2.0006006 minus 6 times 1.0001 plus 2 equals negative 1.9999999. Now let's try Next, let's try x equals 1.01. 2 times 1.01 minus cube minus 6 times 1.01 plus 2. 2.060602 minus 6.06 plus 2 equals negative 1.999. Now let's have 1.5. Substitute 1.5 into the equation. 2 times 1.5 cubed is equals to 6.75 minus 6.6 times 1.5 is equals to 9 plus 2 equals negative 0.25. Lastly, let's substitute 2 into the equation to complete the table of values. 2 times 2 cubed is equals to 16 minus 6 times 2 is equals to 12 plus 2 equals to 6. So this is how the table of values the upper part is the left side, approaching to the left side. And the bottom part of the table values is the right side, approaching the right side. Now this is how the graph looks like. The black marker indicates the limit. The yellow mark indicates the left part. And the pink one indicates the right side.
For number 4, we can derive the function by using differentiation. The first step is to write the function, which is y is equals to 2x cubed minus 6x plus 2. For the second step, we will change y into y plus delta y and x to x plus delta x. It will be written out like this. After writing that out, we will transfer y to the right side at the end of the function. It will become negative, so it will be written out like this. Distribute the negative sign to the y, which is 2x cubed minus 6x plus 2. After writing it, we can now cross out like terms. So the final answer would be delta y is equals to 6x squared delta x plus 6x delta x squared plus 2 delta x cubed minus 6 delta x. For step 3, we will divide both sides by delta x. Now it will become like this. So there. And then, we will substitute delta x in the function to 0. And there we go, our final answer. Y prime is equals to 6x squared minus 6.
So the given is f of x equals 2x cubed minus 6x plus 2. By the sum rule, the derivative of 2x cubed minus 6x plus 2 with respect to x is d over dx times 2x cubed plus d over dx times negative 6x plus d over dx times 2. The next step is to evaluate the first term, which is the d over dx times 2x cubed. Since 2 is constant with respect to x, the derivative of 2x cubed with respect to x is 2 times d over dx times x cubed. Differentiate using the power rule, which states that d over dx times x raised to n is n times x raised to n minus 1, where n is equal to 3. 2 times 3x cubed plus d over dx times negative 6x plus d over dx times 2. Multiply 3 by 2, then the equation should be 6x squared plus d over dx times negative 6x plus d over dx times 2. Then evaluate the second term, which is d over dx times negative 6x. Since negative 6 is constant with respect to x, the derivative of negative 6x with respect to x is negative 6 d over dx times x. Differentiate using the power rule, which states that d over dx times x raised to n is n times x raised to n minus 1, where n is equal to 1. Six x squared minus 6 times 1 plus d over dx times 2. Multiply negative 6 by 1, then the equation should be 6x squared minus 6 times 1 plus d over dx times 2. Lastly, differentiate the last term, which is d over dx times 2, using the constant rule. Since 2 is constant with respect to x, the derivative of 2 with respect to x is 0. Derivative of 2 respect to x is 0. So, the equation should be 6x squared minus 6 plus 0. Add 6x squared minus 6 and 0, then the answer is 6x squared minus 6. So, cx squared minus 6 is the final answer.
Now for our tangent and normal line of the function 2x cubed minus 6x plus 2, the first thing we need to find is our first derivative, and that will be 6x squared minus 6. And to get our slope, we need to input the values of the point, which is 0, 2, and that will be 6 times 0 squared minus 6. And our slope now will be negative 6. And the second thing we need to find is our tangent line. Our tangent line at point 0, 2, and the slope, which is negative 6. All of these values, we will input this to the formula, which is m equals y minus y sub 1, all over x minus x sub 1. And then we will get negative 6 equals y minus 2 over x minus 0. And then we will cross multiply the values. After that, we will get negative 6 times x minus 0 is equal to y minus 2. And to get rid with the negative sign, we will multiply the values with negative 1. And simplify it further, we will get 6x plus y equals 2. And that will be our tangent line. The next thing we need to find is our normal line. Our normal line with the same point at 0, 2. And remember now that the slope of the normal line is the negative reciprocal of the slope of the tangent line. So our slope now is 1 over 6. And after that, again, all of these values, we put this to the formula, which is m equals y minus y sub 1 all over x minus x sub 1. And we will get 1 over 6 equals y minus 2 over x minus 0. Cross multiply the values again, we will get 1 times x minus 0 equals 6 times y minus 2. And simplify it further, we will get x minus 6y equals negative 12. And that will be our normal line. And as you can see in the graph, the green colored line is our tangent line and the red colored line is our normal line.
Now finding the critical points of the function. So we have the function here which is used in the first videos. So these are the steps in finding the critical points. Find the first derivative and equate to 0 to get the critical values or the x value. Then for the step number 2, so I listed also the step number 2, just substitute these x values to the original function to get the y values. So again, our function is f of x is equal to 2x cubed minus 6x plus 2. So as per our step number 1, we need to get the first derivative and equate it to 0. So we write the original function, 2x cubed minus 6x plus 2. F prime of x is equal to 6x squared minus 6. Then we equate it to 0. 6x squared minus 6 equals to 0. Then 6 is common, so we pull it out. So x squared minus 1 is equal to 0. Then x squared is equal to 1. Then we find the square root of the 2. Then x will be equal to positive, negative 1. So we have two critical values of x. X sub 1 equals 1, x sub 2 equals negative 1. So these two are the critical values of our x. Or, the function, the critical values of the function. Then we substitute it to the original function to get the y value. So we just have to copy the original function, which is 2x cubed minus 6x plus 2. Then the values of x will be substituted by 1. So we have here. Therefore, our y values will be just 2 plus 2 minus 6. So that's it. That will equal to negative 2. So our first critical point will be 1, negative 2. For the second critical point, we use the negative 1. Then we just substitute negative 1 to the x values of the original function. Then we arrive at the value of our y, which is 6. So our critical point will be negative 1 and 6. Therefore, the critical points of this function are the following: 1, negative 2, and negative 1, 6. Now we're moving to the maxima and minima of our function. Again, we have the function 2x cubed minus 6x plus 2. Then these are the steps in finding the maxima and minima of our function. Make a number line using the critical values. We already solved the critical values. We have 1 and negative 1. Then we will make this number line. to assign values and substitute it to the first derivative. So we assign number from that area, and that area. Then if the resulting value is negative, that is decreasing. If positive, means that's increasing. So we need to get the first derivative of our function again. So f prime of x is just equal to 6x squared minus 6. Then we assign value in this area. So let's say negative 2. So f of negative 2. Then we substitute it to the x of the first derivative. Then we get 18. So that's positive, meaning that's increasing. Then on that area, let's say 0 in between negative 1 and 1. So 0. So substitute to the x. Then we get negative 6. So that is negative, meaning that is decreasing. Then on that part, on that last area, let's say positive 2. Substitute to the x again. So we get positive 18. Again, that's positive, that's increasing. So positive, then negative, then another positive. Therefore, these are the intervals of our function. It is decreasing at negative 1 to 1, and it is increasing at negative infinity to negative 1 union 1 positive infinity. Therefore, our function assumes a minimum value at 1, negative 2, and maximum value at negative 1, 6. Next, for the concavity of our function, I listed 4 steps. Number 1, solve for the second derivative and equate to 0. 2, we need to create a number line. Number 3, assign values to the second derivative. And 4, if negative, that will concave down. If positive, that will concave up. So our function is still the same. So we need to get the second derivative of that function. So we write the original function. F of x equals 2x cubed minus 6x plus 2. So its first derivative is just equal to 6x squared minus 6. Then its second derivative will be 12x. Then we equate it to 0 per step number 1. Equate to 0. Then the value of our x will be equal to 0. So for step number 2, we create a number line. So we put at the center the 0, then to the right side the positive infinity, and to the left side the negative infinity. So we get the second derivative, which is just equal to 12x. Then we assign values between negative infinity and 0. So let's say negative 1, then we substitute it to the x. Therefore, we get negative 12. So that is negative, meaning that will concave down. Then to the right side, we assign our x value. So let's say, so let's just copy first the second derivative. So let's say positive 1. That's between 0 and positive infinity. Substitute it to the x. We get positive 12. That is positive, meaning that will concave upward. Now the intervals. So for concave down, we have the interval between negative infinity to 0. Then for the concave upward, it will be 0 to positive infinity. So that's how you find the concavity. Now for the inflection point of our function, again I wrote the steps. 1 is get the second derivative and equate to 0. And in number 2, use the value of x to get the y value. Then our function is still the same. So we need to get the second derivative of our function. So we write the original function, 2x cubed minus 6x plus 2. Then f prime of x is just equal to 6x squared minus 6. Then the second derivative will be equal to 12x. Then we equate it to 0. Therefore, the value of our x is just equal to 0. Then, we use the x value to get the y value. So, we write the original function, f of x is just equal to 2x cubed minus 6x plus 2. Then, we substitute 0 to all the x's in our function. Then, therefore, our y value is just equal to 2. So, our inflection point is at 0, 2. So, the inflection point is where the concavity changes, maybe from concave down to concave up, or concave up to concave down. So, that is how you are to find the inflection point of a function.
Sorry, it's DJ.